Hello? Um, Let me see. Hello? 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 Okay. I think that should be fine. Yeah, that should be fine. I'm not sure if that's good or not, but hello everyone! Oh, voice crack. Morning, good evening, or voice cracks. Oh well. Morning, good evening, and good afternoon. My name is Cha, and I'm a Mochi Bichuru. So, it's been a while. I think it's been like a week and a half since my last stream. It's almost been 2 weeks. So yeah, I'm gonna do a drawing stream today, and I think one of the stuff I should address, or one of the things I should address, is probably where I've been for the week. Well, oh yeah, and this week I gained a subscriber. That's cool. That's great. Thank you for whoever did that. That's pretty cool. Thank you. I don't know. Honestly, I'm doing this whether I get subs or not, but you know, it's cool to get someone to subscribe. It's pretty cool. Anyway, so checking if my thing is working. That's the bucket tool. Why do I have the bucket tool on? Hello. Hello. Did I? Hello. Oh shoot. Okay. What? Well. Hold on a second. If I use this layer. Oh no, it's because of my color. Okay. Hello. Hello, me. I filled this layer up. I'm just gonna delete it. Delete. Delete it here. Okay, delete that layer and then just gonna... Wait. No, that's not what I wanted to do. Okay. Sorry, I'm not new to Photoshop, it's just I don't use Photoshop that often. Oh my gosh, that's a background layer. Whatever. Whatever. This is a process, isn't it? It's just a process. Anyway, so I think one of the things I should do is to tell you guys where I've been. So basically, oh shoot. That's my mouse. Ugh. I should have set this up beforehand, I'm so sorry. Okay, so yeah, I should probably tell you guys where I've been. So, in general, or just a what is that? Okay, I don't need that. So, just to simplify some things, I'll say that I live in a province of some sorts. I live very far away from, like, any major cities, in my country. So, like, if you want me to go from, like, my house here to my house in, like, let's say the city, and, like, I say house in the city, but, you know, just somewhere that we live in the city, don't mind the size, my drawing's bad, just live with it. So, if we go from here to here, where, like, the city is, I don't know what to do for city. Maybe I'll just do this or something. Yeah, that's a building, right? That's a building. Okay, whatever. Oh, I think I'm peeking. Let me just turn that down so that I hope that doesn't hurt the ears that much. So if we take the travel time here, that's basically like 3.5 hours. 3 hours. How do I do notations for it? 3.5 hours. Yeah. So it takes me 3.5 hours to get there, and we only stay there. Well, I stayed there for school before, but since the start of the situation, I don't know if I should say it or not, but whatever. Since the start of that, I basically had to move back to the province, and we stay here most of the time. But we have to go back every now and then, so I can go to my doctors, like my dentist and stuff. So we go there every month, and then that's probably why I might not be able to stream. Like maybe one weekend every month. I hope to like subsidize that or like substitute that for some streams on the weekdays, but maybe just one on Monday and then the usual Wednesday thing. Cause I do Wednesdays, Saturdays, and Sundays. So maybe I'll do a Friday one. I'll see. I'll see how it goes. But I also have to do it again this week because it's my grandparents' birthday and we're going back here again, which is cool. Oh yeah. One more thing. I can't actually stream there because my Wi-Fi is pretty bad. We use cellular data a lot, or we use mobile data, so it's just like from your phone. That's where the Wi-Fi is coming from. And then I have to use that to power my laptop, which is not enough for streaming. Like, it's definitely not enough for streaming. I am good at drawing, aren't I? But, yeah. It's not good enough for streaming, so I can't do any streams there, which sucks. And I got home from the province, like, this Thursday, but the internet was down because apparently we didn't pay it. Because our payment didn't go through. It went through the day after it got disconnected, so we had to do this whole fiasco and like getting our internet back online. So now it's here, and now I can stream. It's good. We got our thing back, and hopefully it's good now. Also, one more thing. I got an Ethernet cable, so I can have better Wi-Fi connection. Hopefully, hopefully it works. I mean, it's working now. I mean, when I did it yesterday, it wasn't working all that well, but it's working well now. So that's good. Anyway, I think I should just make this a new layer. Yeah. Okay, so I said that we're gonna be doing some maths today. We'll get to that, but sorry, I'm kind of hungry. I kind of want to do some just general drawing stuff before I do the maths part, because the maths part is a bit interesting. So yeah. Okay. What to draw? I don't know exactly what to draw, but oh yeah, I wanted to talk about one more thing actually. I've been reading like a lot of mangas like recently. That's not a book. I'll just use a phone. That's where I read it on anyways. Don't have any manga stores or animates here where I am. I wish there was. That would be cool. You can only find like weeb stuff in like anime conventions or just buy them online. But they don't actually have like animates here, which kind of sucks. Oh. But yeah. So I've been reading a lot of mangas. I've read like 7. I've completed like 7. Completed like 7. Haha. Bear witness to my drawing process. I am so bad, so whatever. We'll just sort of improvise this for now. So yeah, I've been reading like a lot of mangas recently. And yeah, it's been pretty fun. I've completed 7 mangas, and then I've like I'm up to date on like an extra 3. I think, cause wait, no, I read one last night again, and then I'm up to date with that. So I think I'm up to date. I'm up to date with 5 new up to date. So I'm up to date with like 5 mangas, so those are the ones that are updating. I finished like 7, I think. So those are like completed mangas. I don't know, it's just, I like reading manga a lot. Genre specifically, I like romance a lot. Big heart. Small heart. Yeah. I love romance a lot. Rom-coms, somewhat. Romance with drama, a bit. Not too much, but I definitely still read it. If you want me to suggest a good shoujo manga, I don't read a lot of shoujos anymore. I read a lot of them before, but if you want me to recommend a good shoujo manga, read Reading Nakanajo. It's really good. I don't know, it's one of the more memorable ones to me. Just draw hearts here. Hello. Oh yeah, and when you see like a lot of webtoons, they have like different like little creatures and stuff. I don't want to draw my own. I don't know. They're like those little like fur ball, puff ball sort of things. I think I drew that poorly already. This is like, I don't know. If I say it's a cat, it's probably not a cat. Oh wait. No. I can salvage this. Just like that. And then cat. Perfect. It's a wonder how I made my model in the first place. I'm so bad at drawing. It's a wonder, like, any of this, like look at this. Like, I have to animate this, and then, I mean, it's a circle. It's easier than animating the human form. Then again, I'm not sure if I should just, like, do rough or, like, use line art, because I can use chicken scratches, probably, but... That is not a chicken scratch. What is that? I could probably use chicken scratches to make it look the way I want it to, as compared to doing line art. The problem is, like, the software that I use to both animate and draw in doesn't want to just cooperate with me for some reason. I don't know. Stuff out of your nightmare sort of thing. I don't know, I need a bigger brush, but I don't want to change my brush, so I'm just gonna like... Hello. Hello. Perfect. Perfect the way he is. Looks like he has a baseball cap. Let me just... There we go. He has a baseball cap. Ah, he's cute. I love him. That's one of the reasons why I chose my model, or made my model like this. I just thought, what's cute? This right here. Look at me. Look at me, I'm so cute. I have a weird laugh. Just realized. I like talking to myself a lot. Very good. Is it therapy? I don't know. Why would I even consider it therapy? It's therapeutic, bro. Hold on, let me get some water. So yeah, I said a while ago that I'm gonna be doing my stream. I missed like my Saturday, Sunday stream. But I hope that I'll be able to do the one for Wednesday this week. Yeah, Wednesday this week. So, oh yeah, I should probably explain that as well. Okay, hold on, let me get a new layer. So, this week, basically, I was planning to, right from my from here in the province to here in to the city. They were only planning to stay there for just like 3 days, I think, right? Yeah, because we have some business there, and then we were gonna plan to stay on Friday to Sunday, and then we were gonna go back Monday or something, but then we sort of had other stuff, so we kind of stayed there Monday, and it turned into Tuesday, then it turned into Wednesday, then it turned into Thursday, then it turned into Friday again. So yeah, I wasn't able to make the Wednesday stream, and the Wi-Fi was cut off for both the Saturday and Sunday stream, so I wasn't able to make a total of 5 streams. Which sucks. I love streaming. At least I love it right now. I don't know what my thoughts about it will be further along in the future, but, you know, at the present, it's pretty good. It's pretty good. That's why I'm still doing it. So that's why Monday, today, Wednesday, tomorrow... Not tomorrow, but Wednesday... When Wednesday comes, I'll do a stream. I'm not sure if I want to do a stream on either Thursday or Tuesday. I want to do it on one of those dates, because I have free time to do it. Because I like I said, I'm going to my grandparents to celebrate my grandparents' birthday on Saturday and Sunday. Friday, Saturday, and Sunday, so I'll be gone on these days again, so that's a total of like 7 days missed. But I may do another stream on Monday again. It depends, because we might do some other stuff. We might extend. I have no idea, but I try to keep it consistent. And if my Wi-Fi is working with me, then I will. If it's not, then well, it's not. Huh. Okay. So, I think that covers most of, like, why I was gone, why it's sort of hard for me to stream. I know, I got an Ethernet cable, so hopefully things are fine. Things have been looking fine so far, so I hope that's good. But I did promise math. So I think I have to deliver on that promise, and I guess we have to start on the math section. Well, buckle up, students. We're gonna be doing some math today. So, I should really stop eating in between the stuff. That's good. Oh yeah, I'm eating an empanada. A chicken empanada. That's pretty good. Oh god. I have a special stream planned for Wednesday. And it's also kind of special, like as special as this, but, you know, I'm not sure if I want to base my content around gimmicks and stuff, but that's sort of what I'm doing right now. So, oops, you're not supposed to see that yet. So, let me get my mouse. Hold on, I have to move my setup a bit so that you guys are able to see this. So, oh my gosh, hold on. I am so uncomfortable right now. Give me a second. I'm uncomfortable because my mouse is in a really awkward position. Zoom. But I'm guessing you can already read it. Zoom in. So, a certain human orifice, I think you can guess where this is going, can stretch up to 7 inches before tearing, and a raccoon can fit into gaps less than 4 inches wide. I think we've all seen this before. If you don't know, I won't tell because I don't really know how I want to tell about it. Or I don't really know how to describe it per se. So yeah, I don't really know how to describe it too much, and I don't really want to describe it for, I don't know, just, yeah. If you know, you know. If you don't know, then, well, you'll probably know soon. Anyway, so this is normally just a normal. Yeah, use brush too. Oh, okay, hold on. I have to make a new layer then. Okay. So this is something that popped up before. Like, you see other people talk about it. You saw maybe the Twitter that originated from it. I just sort of censored one of the words, but whatever, you could probably guess what it is. Now, most people see this as a statement. Well, I see this as a challenge. What challenge do we have here exactly? Well, this is where math comes in. So, the human orifice can stretch up to 7 inches before tearing. If we can think of that as like the base, if you think of it in the terms of like a Cartesian plane, for example, if you think of it in terms of the Cartesian plane, that's, let's say 7 inches, that's 3.5 here, and then 3.5 here. So that's 7 inches. So we can say that the radius of that, since it's more or less, when you stretch it out, it becomes circular. It becomes circular so that the radius of that is half the diameter, and the diameter is 7 inches, so that means the radius is 3.5. So we got our radius of orifice, which we will denote as RO, is equal to 3.5 inches. We're doing inches instead of centimeters because the original post came in in inches. Plus, it's a bit easier to calculate since the numbers are smaller. So, And then we can say a raccoon can fit into gaps less than 4 inches wide. Here's something that I have to agree on, that I need all of us to agree on, for example, okay? A raccoon, I don't know how to draw a raccoon. It would be amazing if I knew how to draw a raccoon, just that one specific animal. So it's probably got like not that long of a nose, but we'll just keep it, and then it's probably like that. That looks more like a mouse than a raccoon. And it's got that striped body. And I don't know where its eyes are, but it has like specific eyes. Yeah, that's a raccoon, right? And it has the legs. Yeah, it has its like little legs. That's a raccoon, right? This is a raccoon. I don't know if I spell raccoon right. Please forgive me if I spell it wrong. So that's a raccoon. Now, if we want to say that raccoons can fit into gaps less than 4 inches wide, we can consider the gap as like sort of circular as well. We can consider the gap as circular, and then they can fit in it at 4 inches wide. So the diameter of this is equal to 4 inches. Now that means our radius, which is half the diameter, is equal to 2 inches, which is this, and then we take this, and then that's our radius. So we can say the radius of the raccoon, RR, is equal to 2 inches. Okay, we have that established. Now, we have to get a few more variables just to make sure that our calculations will sort of have a better chance of like coming into fruition. So, this one states that the according to Google, a raccoon is 24 to 38 inches. Just so that you guys can see, there we go, 24 to 38 inches. We sort of want to go with the smallest one for now, just for simplicity's sake. So we're gonna go with that one for now. We're gonna go with 24 inches. So the radius of a raccoon, the length of a raccoon, or let's say height. Let's say the height of a raccoon. Like if you were to measure it in humans, the subscript R, just to denote which ones we're sort of saying, is equal to 24 inches. Okay? As for now. Now I want us to agree that a raccoon, when it fits in this gap, a raccoon can be considered a cylinder, because in order to fit through that gap, it more or less has to have like a cylindrical sort of shape, so that it can fit into like that sort of hole that you would call itself a gap. Shoot, I want to get this right. Yeah, close enough. Okay. So it has to fit in the hole, and then we can assume that this is the raccoon. Like, just out of basic shapes. We're just gonna make an assumption here, okay? So that's the raccoon. This is also a raccoon. This will not make sense. And then this is the gap. And then the shape of the raccoon is a cylinder, okay? Cylinder. I hope that's the right spelling, because I'm not. Whatever. So we just have to establish that a raccoon is shaped like a cylinder. Then we can get on to everything else. If you have something against that, that's fine, but I just want to do this for simplicity's sake. Okay? Now, if we go back up, the human orifice is 4.7 inches deep. So we can also sort of say that as the height or the length. So if you were to say that this is like the opening of it, so this like line, then you can say that this is 4.7, and then we can just draw a line there, and then that's like the sort of shape that we get. Ugh, excuse me. I don't know if you heard that, but I burped. Excuse me. Okay, so the height of the orifice, or length, depth, whatever, this will be important later, okay? The height of the orifice is equal to 4.7 inches. Okay, 4.7 inches. I would like to show you the Google thing, but I'm afraid that I might click on the images tab and be flagged as inappropriate once I do so, because I could possibly do that. Okay, we have all of our sort of variables in place. We have our variables in place, we have our sort of things set. Now, I did some of this ahead of time just to make the process more streamlined, okay? Now, one of the things I will do right now is to get the volume of the raccoon. Because what we want to do, we want to compare, because people say you can fit it inside you, but I want to know how much you can fit it inside. So like, let's say, like you have a glass of water, or you have a glass, right? You have a glass, shoot, you have a glass, oh gosh, please be good at drawing it, and just dotted lines on the end. So let's say you have a glass, right? So this glass has a certain volume it can contain, okay? That's the inside, that's what the shape is. But that's how much water it can contain. That's how much volume it can contain. Now you have to know how much volume of water you sort of want to put inside. I don't remember. I just drew waves. That's waves. So water, water and glass. So we want to know how much water we can fit inside the glass. Okay. Now, for our situation, we can think of the glass as the human orifice. So we can say the glass, we can say the glass is equal to the orifice. And we can think of the raccoon, okay? The raccoon. Did I spell that right? Okay. Raccoon. Raccoon. Yeah, okay. I spelled that sort of right. The raccoon is our water in this situation. We want to know how much of the raccoon, or even if the entire raccoon, can fit inside the orifice, or in this case, the glass. So, in order to get that, if say the I want to move this because there's actually less space to work with now. There's still some space. If the raccoon, I'll just call it rack so that's shorter. If the volume of the raccoon, let's say V rack, is less than the volume of the glass or the orifice, VR, then we can fit a raccoon inside it, or we can fit the entire raccoon. Then, raccoon fit. Rack fit. If it's less than, then it's not. So it's less not fit. My gosh. Okay. So, okay, we have that out of the way. I think I should introduce you to what I cooked up in Desmos. So Desmos is a cool graphing calculator that I use. That's it's pretty cool. It's pretty cool. So let me introduce you to what I have in Desmos. Desmos, here I have an equation, basically, that outlines the sort of shape of the curve, or the shape of the equation. So the shape of the equation that we have here is sort of gotten by 1 over 3/2 x to the 4th, and that's this sort of thing. But we want to get the side of it. So, hold on. If you look here, this sort of point, if you look at this point here just over here, this intersects 4.7 at 3.502. So it's not exactly there, but it's close enough for us to like do our calculations. Now, how are we going to get those calculations exactly? Well, we are going to get these using the properties of integrals. This is a lot more advanced. I think this is more college level sort of mathematics. So, please bear with me, okay? But what we're going to use is called disks and washers method, using properties of integrals. And what we're going to do, basically, the basic concept of it is that you have let's say, this is a Cartesian plane. A Cartesian plane is basically where you draw your graphs in. And let's say that you have a... Let's say that you have a... okay. Let's say that you have a equation that's graphed on the Cartesian plane. Let's say that this is your equation. Now, what we do here is that we can get the area underneath the curve. So we can get the area underneath the curve here. And then you use, in order to do that, you use properties of integrals. So let's say you stop that here, and let's say that's like 0, and then this is 3. So, in order to get the equation here, the basic concept, sorry, I'm fumbling a bit. I don't know too much about the topic, but I know how to apply it, so whatever. You have your equation. Let's say this is x squared, y is equal to x squared, y is equal to x squared, which this is probably not it, but it's a close estimate, so whatever. If we were to put that into integrals, this would be 3, 0, and then x. But the basic concept of this is that we want to rotate this around, let's say, the line, let's say around the x-axis. This is the x-axis. So we get a sort of shape. If we rotate this around here, then we would get a shape that looks sort of like this, I think. Yeah. It would look like this. It looks like a weird cone. And in order to get the, like, volume of the orifice, we have the orifice, which is this shape, but we cut it in half because this is basically just the other side of it. And then we sort of project it around so it looks like this sort of shape, which is applicable to what we're gonna use, okay? That's why we're gonna apply it. That's why we're gonna use this to apply it, okay? Now, the format for this, to get this, using the discs and washers method, is to get... Basically, since it's a circle, and then you're rotating it around a thing. Is it because of pi? I forgot. I'm sorry, I'm not gonna be doing good at explaining. Just know that this is sort of how you do it. So, in order to do that, in order to get it, we need to get pi and then f of x squared, and then dx y is equal to this. So that's the entire thing. Right? No, it's not y. The volume is equal to this. The volume of the shape is equal to this. So you get all of the numbers, you get all of the, like, results when you plug in the 3 to the 0 in the integral, and then you use the integral to calculate the sort of area under the curve, and then we use pi r squared, because this is just basically pi r squared, but instead of r we use f of x because the radius is ever changing as you move along the graph, in order to get the shape of the volume of the thing when it's rotated around. I don't think I explained that too well, but just please bear with me, okay? So, now, what we had a while ago, our equation a while ago, was 1 over 32 x to the 4th, y is equal to that. Now, here's the problem. In order to do this, it has to be sort of, we're supposed to get the area here, right? Instead of the area down here. In order to do that, we have to express this not in terms of y, but in terms of x. So in order to do that, we have to transpose the entire equation. And I've already done that a while ago, so I've done that, and we got 32, x is equal to 32y raised to 1/4. So basically, we transpose this and we get x is equal to the 4th root of 32y. Yeah, that's what we get. So that's what we have to work with, and then that's what we have to plug into the integral. If we plug it into the integral, then it should look something like this. 3, 0, or volume is equal to... The volume is equal to, hold on. the volume is equal to 30. It's not 30, it's 3.5, sorry. I should probably mention this. My head's all over the place. I should probably mention this. The width that we're using right now is the width over here. So this in the x-axis is equal to 3.5. And then, yeah, approximately 3.5. So that's why we have the 3.5, and then that's why we have the 4.7. So we can find where the axes sort of like intersect with one another. And then we're going to use that. So it's 3.5. And then we're assuming that this is the shape of the orifice. So if it's 3.5, then we have the max sort of like the max sort of thing that we're gonna get from it. So in actuality, it's up from here to here. Okay, sorry, I made a mistake. So that's the base, and the 3.5 is important just for like finding out what we have to do with the graph. And then since I already got the graph, we can not ignore it, but you know, it's not too important right now. So the actual values that we have to put is the height of it, or the depth of it. So from the depth, since we're going to be using it in this way, like it has to be perpendicular to the axis rather than this way, rather than this way. We can say now that it's 4.7 to 0. We're evaluating this integral from 4.7 to 0, and the integral is pi times 4, the fourth root of 32y raised to or squared dy. Thing about this is the pi sort of gets outside, so it's equal to. You just add the pi in. If you have a constant in the integral, you can just remove that, so it doesn't matter to how you evaluate this integral. I know I could like manually evaluate this, but that will take too long, and I don't want to. So what I did was I booted up the integral calculator. Just to show you that this works. This is the equation, and then this is what it looks like. It's the exact same. So I booted up integral calculator. If we let it go, we already have the result here, and we sort of transpose everything. Now, the definite integral of this now is equal to 120. So that means the volume of this. I know we're sort of skipping a lot of steps, but I'm just telling you the sort of steps of the process, not the actual process itself. Because I don't understand it all too much myself. I just know that I should apply it here. So the volume of the orifice is 120 let's say 0.72 inches cubed. Okay? Now, that is the volume of the orifice, or how much the orifice can handle, or how much volume the orifice can just how much the volume of the orifice is available to take up space for. Oh my gosh, I don't know. Whatever, just the volume of the orifice when it's stretched, when it's completely stretched. So I just want to clear up some things. Why do we need the height of the orifice? We needed the height of the orifice in order to get the integrals here. So that's 4.7. We needed that so that we can say it's the 4.7 to 0. That's where we're going to evaluate it in. And why do we need 3.5? We needed 3.5 because we needed 4.7 and 3.5 to intersect in order to get the width of the orifice at the same time where it intersects with our integral. So we sort of have that set because that's how we get the shape of it. Okay, I'm sorry, I'm just really rambling because I didn't really plan too much for this. I just have the equations and then the stuff I did beforehand. But the explanation, I did not plan for the explanation. Okay, at least we have an easy part here. So, the raccoon This is a lot easier. A lot easier. We only need to solve for the volume of a cylinder, which here, oops, the volume of a right cylinder, which we were gonna assume raccoons are. I know it's not exactly that, but since they can fit into gaps that size, and then since they're that long, we'll just assume they're cylinders, okay? Just for now. Just for now. Okay? The volume of a right cylinder is pi r squared h. So, the volume of the raccoon is equal to pi r squared h. Now, we already have r squared. We already have r squared and h, and pi is a constant. So, r squared, r is 2, and then the height of the raccoon is 24. So we can substitute those values as the volume of the raccoon is equal to pi times 2 squared times the height, which is 24. A bit of easier solving here, we can say that is equal to pi to the 4 times 24. B of r is equal to pi of 96, and I hope I'm right. But just so that we're more or less sure about this, we'll just plug this into our scientific calculator in Google, which is pi times 4 times 24. So, we get an answer of 301.59. So the volume of the raccoon is 301.59. So we can see that the entire raccoon, will not be able to fit into the volume of the orifice. So you can't fit an entire raccoon into the volume of the orifice. However, if we sort of do this, 120, sorry, inches cubed. If we do 120.72 all over 301.59, bring up the scientific calculator from Google. Bring it up. So, 120.72 divided by 301.59 is equal to 0.4002. So, approximately 2/5. So you can fit, if it's a very small raccoon, like a small, like averagely small raccoon, then you can fit 2/5 of the raccoon into the orifice in question. Okay, so just according to Google, using the variables that we got from Google, we can say that we can fit 2/5 of a raccoon up that orifice. We're not done here, because I sort of want to make it just a sort of generalization. So, remember how we said that the raccoon is 24 to 38 inches? Well, let's take into account 38 instead. So we'll sort of leave off where we were here, and then let's say that it's BR is equal to pi 4 times 30, sorry, that should be times, I'll just use x, there's no x here anyway, times 38. If we plug that into our calculator, then we get pi times 4 times 38. Yeah. We get the volume of the raccoon is equal to 477.52. So 0.52. So the volume of the raccoon is 477.52 cubic inches. Now, if we do the same thing we did before, 120.72 all over 30, the volume of the raccoon now, which is 4 177.52 inches. I'm just gonna ignore that for now. But if we do that, then we can say that 120.72 divided by 477.52 is equal to 0.2528. So approximately 1/4 of a raccoon. So the range that you can fit how much of a raccoon you can fit in that orifice is between 0.4 0 less than equal to, so x, and then less than equal to 20. Wait, am I doing this right? No, that's the other way around. Sorry. So it's greater than or equal to 25, but less than or equal to 0.40. These are adult raccoons, by the way. So these are adult raccoons. I don't know about baby raccoons. I'm sure you can probably do that, but that's not what we're concerned with right now. Okay, we're concerned with adult raccoons, and that's the math behind it. A few things that are problematic with my solutions. Okay, the graph is fine, but I can't generally say what a human orifice looks like because I am not going that far in the internet to see what it looks like. So I made a general estimate just on like what you would probably put in there in order to make an estimate of what shape it would be when it's stretched. Otherwise, there's also another sort of equation that I brought here. I mean, I could do that as well, but I'm not sure if I want to right now. Because here's the one where we sort of assume that it's stretched out, but the bottom's also stretched out, which I think makes more sense, because if you were to stretch it out, you would also stretch the bottom out, not just the front end, but the back end as well. But if you were to not stretch out the back end, the bottom end, and then if you were to just stretch out the front end, because in my eyes, this is the shape if there's something in it, and I think the shape with something in it is the best shape we should use in order to see if a raccoon can fit in it or not. But this is the shape. Hold on. This is the shape that I believe it should be if there's nothing in it. If you just stretched it to make it so that it stretches to 7.5, I'm at 7 inches. Once again, we have here, it's not exact, it's actually a bit less than before, like a lot less, but it's close enough, I guess. So we have here 4.7 at y is equal to 4.7, x is equal to 3.42. It's a bit less accurate, but it's somewhat accurate enough, okay? So this is probably the shape it would be if you were to stretch it without putting anything in it. But if you were to put the raccoon in it, then this is probably the shape it would be. So I sort of calculated for that shape instead. I don't want to calculate for that volume right now because I did not do that ahead of time, and there's quite a few stuff that I have to prepare in order to do that. Not only that, but I think this is the better calculation because of what it looks like. I haven't seen what it looks like, but probably is something along those lines. Okay, so I hope y'all learned something today. If you have anything to take away from this, is that you cannot fit a raccoon or an entire raccoon up your thing, up that orifice, or you probably can't. Okay, you can fit 2/5. You can fit 2/5 of raccoon, up to 2/5 of raccoon, and wait. Yeah, you can fit up to 2/5 of an entire raccoon or up to 1/4 of an entire raccoon depending on the size of the raccoon. Because, you know, the raccoons are not completely like, they call this, they're not all in one size. They have different sizes. You have to sort of know that. I know that this has been like 30 minutes of me just rambling about this, but it's an interesting topic. And then if you want to like say, where is math useful in real life? Here you go. is it is it a good use of your time? I don't know. I've been spending a week just solving this. Not really a week solving this, but like I've been procrastinating for a week and solved it like 3 hours ago. I don't know. It was fun. It was fun. Although I also have to practice because I have some stuff for some tests coming up on this, so should be fine. Should be fine. I should be fine. But yeah, I hope you all learned something. Maybe application in math. Maybe just the entire thing here. So yeah, I've already answered your question. It was a great rambling on 30 minutes. So what I will say here, however, is that this was sort of like a raw stream, as in like, I did plan for this, I did plan for a lot of this, and I did plan to sort of show this, but it's really rambly, and like, I go back and forth a lot, which I know is probably not going to be too entertaining. So what I probably will do is that I may post a video detailing the entire process, hopefully under 5 minutes, like how they do in like normal math videos. Maybe 5 minutes, maybe 8 minutes. I don't think people will watch it too much, but I'll see. Because this is definitely something interesting. Interesting use of math, definitely. But I really think that I want to make this into a video. I'll just see if I have time to do it, because I can only do it when my family is not here, and it's hard to do it otherwise, because you'll just hear a lot of background noise, a lot of stuff that I don't really want you guys to hear, and it's just mostly white noise, but at the same time, I guess it's fine. This is a great stream. This is a great stream coming back. I had fun. I'm gonna post this on Twitter as well, if anyone will understand the nonsense that sort of unfolded here. Maybe somebody will be interested in like checking out the channel. I don't know. That's a raccoon. just know that. Oh wait, I should probably. Ooh, no. Probably do. There you go. Like I said, this is not a topic that it's just a topic that I sort of learned in school, and just passing it on as like something I remember, something that I can apply, something here. So I'm not really an expert in this sort of field, but I hope that I got you guys to learn something. Even though it's also sort of foggy for me, but it's a great stream today. I have a great stream plan on Wednesday, and I think I'll end it today. Not too much in terms of drawing, but if you came here for maths, well, I hope you got the maths you wanted, or the maths you deserve, because this was definitely very fun. Okay, enough rambling for me. I guess it's time for me to say goodbye to y'all. Well, that's all from me. My name is Cha. Have a great day, and I will see you soon. Thank you for watching.